Hello viewers and welcome to this series on laboratory measurement in public health engineering. Raw water, as we know, has many suspended impurities present in it. These are due to fine particles of soil or other material. Many times bacteria also remain present in suspended form. Suspended impurities are visible to the eye if they are present in substantial quantity. However, in case of treated water, because their concentration is very low, they may not be perceptible visually. The simple method of quantification of suspended impurities is to separate out them by the process of filtration. In this program, we will see as how do we measure suspended impurities by membrane filter technique. The apparatus that can be used for measurement of suspended solids is either a gauge crucible assembly or a membrane filter assembly. The gauge crucible assembly comprises of a gauge crucible having a glass fiber filter base with 2.1 to 5.5 centimeter dia and capacity 30 to 50 milliliters. Now, this can be placed on a flask of suitable size, or alternatively you can use any conical flask and through the funnel it can be placed. The water sample is filtered and the amount of suspended impurities that is retained on the crucible is measured after oven drying. The pore size of the crucible is 1.2 micrometers. The membrane filter assembly that we are going to use in this program comprise of a flask of 1 liter capacity with ground glass top, a glass base with tubulated cap. This has a filter base and the bottom is ground glass. There are two tubes, one for connecting it to the suction pump and the second is to draw water after filtration. A funnel with a ground glass seal of 300 ml capacity. Now, all these items are having ground glass so that they fit in properly and make air sealed joints. We also need a clamp for joining them together and a forceps to hold the filter. In addition, we have a suction pump which is free from vibrations and also noise. The pressure can be increased or decreased using these knobs and the measurement is displayed here. We also need a porcelain or borosilicate dish to place the filter, an electronic balance of capacity 150 to 200 gram and accuracy of 0.001 gram. The filter paper of pore size 1.12 micron is used and a drying oven. First, we shall put different components of the assembly together. Take the glass base, place it on the flask. Now, we shall take a filter out. First we shall note down its initial weight. The filter should be dry. If it is not dried, then we may put into oven for some time and get it dried. So, measure the initial weight and record the value. Now, take the filter and seat it on the filter base. Now, place the funnel at the top and hold them together using the spring clamp. Now, connect the silicon tube of the pump Now, the assembly is ready for measurement. So, we measure 1 liter of the sample. Now, here we are using a groundwater sample. Pour some samples, say about 150 to 200 ml. And let the filtration take place. So, we can see that under the action of gravity, it is quite a slow process. It will take some time. So, when we begin the pump, the suction will start and the process will become faster. So, we will keep adding water as it goes down. As the process continues, it may be possible that the filtration gets slower because of absorption of suspended impurities over the filter. So, we can increase the rate of filtration by applying more suction. If we are working in dusty environment, we can use this cap to cover the sample, but here we do not require this. Now, after the filtration is complete, switch off the machine. If required, we may put some distilled water on the sides of the funnel to remove any impurities clinging to the surface. Now, take out the funnel and lift the filter paper using the forceps. Now, we can see that the suspended impurities have been retained on the filter. Now, first we will dry the filter in the oven at 104 degrees centigrade for 1 hour. Allow it to cool in a desiccator. Determine the weight of the filter, record the value in the proforma. The concentration of total suspended solids is found by using the formula W2 minus W1 divided by sample volume into 1000, which in this case is found to be equal to 10 mg per liter. For highly turbid waters, the sample should be diluted in order to avoid clogging of the filter. In such case, however, the value of suspended impurities obtained should be multiplied by the dilution factor to obtain the concentration. The suspended impurities values are not of direct implication for potable water, because here we use turbidity value to measure the concentration of suspended impurities. However, for wastewater it is of great significance. For industrial effluents discharging onto the land, the value of suspended solids should be limited to 200 mg per liter, and in case of discharge into the sewer, the value should be limited to 600 mg per liter. Thank you and goodbye.